Hi there, and welcome to this little presentation. I'm bringing this presentation to you from my backyard since we're going to talk about climate and weather. It's a beautiful day out here, and so I just want to give you this little prelude to the video or presentation that you'll be seeing, and kind of the reasons for it. And I'm hoping that as you're watching this, that you clearly have an interest in learning a little bit more about climate change and about the historical records and about what is really going on. Clearly you have an interest in it, otherwise you would not be watching this, and hopefully you're open enough to hearing what I've got to share with you. And so I have a teenage daughter at home, and very much I notice that for her at school, and perhaps you are going to school as well, or perhaps you are a teacher, as in this household we have teachers as well, and so the curriculum and narrative at the schooling is all about the current hypothesis that CO2 drives the temperature in the climate, and therefore all the experiences that you have in terms of this beautiful sunny day and weather and the variability in terms of climate is all due to the CO2 records. And I'd like to present to you something a little bit different, something you don't necessarily hear about in the mainstream media. You certainly don't hear it from politicians, you certainly don't hear about it from TV personalities and movie stars, and it seems that the current narrative that is out there that you hear all about is simply repeated and regurgitated and is not to be questioned. In fact, you have a lot of sentiment that you are so-called a denier if you're a little bit skeptical or unclear about, asking questions about how does it actually do that, and how do we know about that, and is that actually true? Noting, of course, that I was always taught that science is a pursuit of truth, and that when you have a certain hypothesis, it's to be tested, and that even though that there might be some kind of consensus or acceptance of a hypothesis out there, in light of or in the absence of any other really strong contestant hypotheses or ideas, that it should always be about trying to falsify it or trying to test it and see whether what you think is true is actually true. And so it's kind of anti-scientific that you don't have any debate and a sense of consensus. So this is why I'm kind of presenting this to you, to kind of throw something else in a mix and test that to you. And if you are an honest truth seeker, and truth is absolutely important, of course, for various reasons, and I'll highlight that in my video as well, that the answers really aren't that simple, and you can't just distill a whole complex science into a simple kind of, this is the control knob. And even if it were true, the answers in terms of policies, etc., are not that simple either. But perhaps I will go into that a little bit, but perhaps not as much. There's a couple of books. I'm in Australia, and there's a couple of books that the Institute for Public Affairs have put out that I've been kind of sponsoring as well, and I highly recommend to you that you read books like this that present from facts and observations and the science, public science, from real scientists in the climate sphere, geologists, physicists, atmospherists, all of those kind of people, and they share with you what is actually going on, noting there is a lot of manipulation going on as well. And I'd like to challenge my children, my daughter, and I'm hoping you as well, like to challenge our children to become independent critical thinkers, not simply just to become puppets and regurgitate or spill out whatever they've been told to think. I don't send them to school to be taught what to think. They actually go through school to learn how to think, because it's a complex world out there, and we need to be complex problem solvers, and not just simply automatons that look up a particular reference and they say, well, this is what truth is, because that's not how you become independent, right? So that's why I've got this video. Hopefully it is formatted in a way that is useful to you and you can share and you can watch. And if this is in a classroom, I hope that this makes perfect sense to you. So what we'll be going through is simply where is agreement? Where do we actually agree on the climate science? And what do we kind of disagree on, or where are we trying to figure out where the differences are? I'll present some facts to you in terms of what the geological records show and where things are at in terms of context. I'll show you how many scientists, or a lot of scientists that actually are. That debate isn't clearly not over, and science, the debate is never really over. And I also have a few questions to throw at you that you could use in a classroom or use as homework to kind of test some of the logical mathematics behind it and put some context around it, because sometimes the context is missing as well. And clearly everything in life is a complexity of propositions and interdependent factors, and while we can talk about some little aspect in isolation, there are many facets of life that need to be taken into consideration as well, and certainly a global issue like the climate doesn't simply take a single household or a single nation to bring, if there are any particular answers, to bring those answers to the table either, right? So that's where I'm at. So we'll go through some historical observations, through some geological records, explain CO2, the molecule, and some of the facets and factors of that particular molecule as well, from world's leading CO2 expert, and some of the mathematical limitations and a bit of a reality check there. Before the other thing that I wanted to do as a lead in is first of all just say that climatology or climate science is not the same thing as environmentalism. So just because somebody kind of questions the current hypothesis that is being presented to you in the mainstream media doesn't make them, environmental vandalists, right? Because there's a very different aspect to look after the environment and fighting real pollution versus some hypothesis on a natural occurring substance that is absolutely critical to life. I hope you enjoy this. Let me know what you think. Let me know. Put it in the comments below, and enjoy. We'll talk to you later. Peace for now. Okay, and welcome to this presentation about the truth about climate change and discussing if it is really so simple. So it's really made by me as a parent, in part for my daughter and other children, as well as for other parents and future generations, in the hope that it's presented in a way that is easy to follow and makes sense. It's not meant to be an absolute comprehensive, detailed guide by guide expose on the science behind it, merely just a summary of ideas. It takes long enough to do that, and to kind of stimulate some interest, and to show that there is a different perspective out there, and that there are a range of detailed sources you can go through, and I'll show them with you where you can go to actually go through the absolute detail if that is your interest. And you can do what I've done over the past few years and watch absolutely hundreds of hours of these presentations by climate scientists, professors, PhDs in the field that have their credentials tested, they have publications, and peer-reviewed science, and tenured professors and all of that. So these are not your average people. So when they say listen to the science, well, that's exactly what I've done and what I'll share with you. So why does it matter, and why it's not that simple? Right? Even if the answer was simple in terms of what the problem is, if the hypothesis that CO2 is the single and control knob of climate, there is still a lot of issues to consider, and most of the people, when we talk about this, and the policy makers, and it's easy for students of middle class income, parents and families, and people that live in the inner city, and the students and 20-year-olds, as well as the academics and professors, people like us that live in a developed nation, relative prosperity. We can always talk about these things, but if we're talking about a global issue, we need to take into consideration that even if the problem was simple, the answers are not very simple, because we do have billions of people in poverty, and current global policy making by politicians hamper these poorest in their prosperity. And of course, people in Africa and India and South America said they require also reliable and affordable energy. This is what we're talking about, energy, right? And they are dying of cold, as well as we have some old people in developed nations too that can no longer afford their electricity bills. And of course, that's a human consideration. That's a moral issue as well, right? So we can't just throw that context out. It's not an all or nothing, and that's sometimes what this discussion seems to be, at any and all cost. I wanted to put that up front, that there are other matters to consider and why it's really not that simple. The other factor is, of course, that we're talking about a hypothesis, right? And it's a proposition. And if we are wrong and we're throwing all the eggs into one basket and we can't question it, we are spending absolute enormous resources and effort on a fallacy if that is end up being wrong. And of course, those resources, that time, that effort, that energy is then taken away from solving real and urgent human problems and environmental needs, right? So if you're having $100 billion spent on developing solar panels and it doesn't really do an awful lot, well, that money could have potentially gone to solving the water crisis in some areas, could be solving the plastics crisis, etc., and other factors, right? So, some people tend to think that money is you can just print it and there's a never-ending bucket of Tim Tams and we can just do more and more and more and more and there's never a limit to it. But that's not reality, right? Politicians can promise the world and they can do everything on paper, but when it comes down to reality, there is a limited number of resources, a limited number of hands, a limited number of minds that can be dedicated to certain problems, right? And when you're focusing on one problem, you can't solve another. So it's important that we get it right for that particular issue, because there are unintended consequences too, right? So the other point is that the current renewables solution has an untold hidden environmental cost as well, and is ineffective and massively expensive. So we're talking about windmills, right? Wind, of course, is intermittent. If the wind doesn't blow, or if it blows too hard, then we can't generate electricity from those windmills. And those windmills are known to kill an awful lot of birds, and particularly the prey birds that, in some cases, those prey birds are the ones that actually feed on feral cats. Feral cats, of course, are now growing in numbers, and they eat the smaller birds, etc. So, and of course, they rust and they fail, and so there's a problem there. Solar panels, of course, and batteries, they are made from incredible, rare and toxic and materials, and what do you do with that? There is a lot of, if you look at the whole of life, end-to-end aspects of the so-called renewables, and the land use and the displacement of fauna as well, animal life, then you go, well, you've got to take that into consideration. A lot of the time we don't hear about that as well. Other areas where we talk about having zero emissions, we talk about zero carbon dioxide emissions. Some areas like where we live, I live in Canberra, it's the capital of Australia. We have hydroelectric energy, so having electricity free, CO2 free electricity is easy for us here. On top of that, I've got some solar panels on the roof because it made economic sense in the current market. But in other areas, perhaps like France, they have nuclear energy, which is basically a no-no here in Australia for some reason. And the debate, we can't seem to have that debate, where it would be absolutely great to have that, because I think the answer in terms of longevity and reliability points to nuclear energy. And the technology is very mature. There's certainly no Chernobyl anymore, right? So it's very different. But it's possible in some areas, and it's okay in these areas to have those kind of policies because it's relatively easy. But in other areas, there is no nuclear energy, there is no hydroelectric. It's just very, very difficult. And so they have to rely on coal and gas. Now, coal, of course, is incredibly energy dense. It's like the original battery storage from the sun, right? That's where all of the energy is stored. And so when we use that and it burns up into water vapor and carbon dioxide, is relatively clean. But that's the discussion that we're in at the moment about CO2, whether that really is the problem or not. But the problem is that it's not very simple for certain areas to move away. We have in South Australia, disconnected, had a problem with the link back to the grid in Victoria, another state, and so they no longer have any coal-fired power stations, and they were relying on the wind energy, and they ended up not being able to do that. The power went out for a number of weeks. They had to turn on diesel generators, which obviously nobody talks about, hush hush, right? So it's really not very simple. And to make steel and aluminium and all of these kind of things, you need to have a lot of heat, a lot of energy, and you just don't get that with solar panels. So the answer, it's not that simple a solution. Sounds good in the classroom, sounds good on TV, in the news snippets, sounds good, when you're at some kind of rally, but when you look at the life and the complexity of life, the answers, you need to take into consideration those policy factors as well. So listen to the expert, climate scientists. That's all, what they say. I agree. We should be listening to scientists, the people, the experts in the field, the ones that have been looking into this for decades, right? Not politicians like Al Gore and that make their money from presenting it, or media, TV presenters that keep pushing the same narrative because it, hypes up their base or voter base, or TV personalities that make their money from documentaries or, all sorts of other things. Simple things, it's really, we can't have these 3-word slogans. We actually have to look at it and then look at and have this discussion with scientists, right? And a scientist is not defined because they agree with your perspective or point of view. Scientists are the ones that are seeking for truth and leave no stone unturned and are willing to question their own position and hypothesis. They absolutely prioritize the truth over and above their feelings and own interests. That's what it's all about, and that's what spirituality and philosophy is all about as well, and that's what I'm all about as well here on this channel, Freedom Philosophy. So science is about reality and truth through a skeptic and honest observation and testing of hypotheses, and it's not about popularity, it's not about consensus, it's not about feelings, and it's not about politics, right? So the whole talk about consensus is just a distraction and a misnomer, and it's really not scientific, right? Years and years and years ago, people thought the earth was flat. There's still some people that believe that. Until one person dared to speak out against the church and a narrative, and at risk of his own life showed, through a test that this is what it really is. Went on a boat and actually they thought he was going to go over the edge, right? Did not happen. For 100 years, they've been kind of trying to deny the quantum mechanics observed by Einstein and, others, because they felt it's too spooky, too weird, can't be true, so we will not accept it. And yet, it is. So just because somebody is unpopular or comes out with an unpopular proposition doesn't make it wrong. The truth is all about unbiased rationality and facts, right? Reality is not decided on the basis of morality or personality or emotions like fear. It's the same with religion too, and spiritual philosophy. And, reality is not based on what you personally think it is. It is based on what reality is. Reality is what is. That's the simple fact of the matter, right? So true scientific integrity then leaves policy making and a manipulation of perception like marketing to politicians, marketing experts and magicians, right? Scientists don't get involved in that kind of rhetoric. They just present the facts and you do with it what you want, right? And that's their role in society, and I hope that that's where they ought to stay. So as soon as they speak out from a policy perspective, then you got to worry a little bit. Teachers and students should be free to pursue the truth. That's another thing. Truth matters. And in climate science, there are real-world implications with impacts on real people. And you can't learn or shift your position, from knowing one thing to another unless you can be exposed to the truth. And so that's the part of the risk of being exposed to the truth is that you might propose with different options, and some might be more true than others. But that's why you have these kind of discussions, right? This is what science is all about. This is what academia is all about. This is what learning is all about. This is what philosophy is all about. I bring philosophy in it every now and then in terms of a comment because that's what this channel usually is about. But, it has no bearing on absolute science because, you're not going to, they go together, they kind of work in harmony. But obviously, I'm not philosophizing here, right? I hope that you make sense. Let's critique out of, because all the time, when I talk to people, and perhaps you have the same thing and you hear it in the news, the debate is over, the science is settled, there's a 97% consensus, so, forget about it. We're not entering into this discussion. Well, I'm sorry, but that's not how it works. Scientific facts are not decided by consensus. Consensus is the realm of democracy and politics and voting, right? Boardrooms, that sort of stuff. All it takes is a single person to falsify a hypothesis. So, as I said before, the Earth used to be the center of the universe and revolve around the sun. But clearly, that the sun revolved around the Earth, and we can say the sun comes up and the sun goes down, but really, the Earth revolves around the sun and so forth. So when you get into the realm of politics, often the politics and popularity and populism, kind of starts to corrupt the science and the message. So we've got to kind of keep these things separate, right? Al Gore, of course, he's a former politician making lots of money with his inconvenient truth, but that original presentation was legally proven in the UK courts to have 9 false statements, and I don't think they've ever really been redacted, and he just made an inconvenient truth point too. Now we have, David Attenborough as well, who's kind of manipulating the facts with his polar bears and things like that. So there's a lot of stuff going on there that, trying to feed a particular narrative. The IPCC, a quick word on that because it's all about the IPCC. The IPCC is a governmental panel. So it's been put together by politicians. And while it has experts contributing to it, the actual final reports as they are presented to the politicians, are written for a political audience and for policy making. And so the policies and the reports themselves are finalized and prepared by bureaucrats and not per se by scientists. And we have a whole range of original contributors that are speaking out against the IPCC final reports in the way that the statements are shifted and changed, and so the findings become misinterpreted, and what they said, the way that they saw the data, is being shifted and misinterpreted and misrepresented and pulled out of context. So you got to be aware of that as well. Now, let's just move on. Obviously, there's a lot of agreement too, right? It's not like one is polar opposite here and the other one's polar opposite there. The same thing in life, and there's enough division in life as it goes on already. Let's just have a look at what we do agree upon, right? So CO2, atmospheric CO2, carbon dioxide, sometimes it's called carbon. People call it carbon. A former Prime Minister, Julia Gillard, called it carbon, and to call it carbon tax. It's not carbon. Carbon is an actual, a particle. It's what everything is made of. But carbon dioxide is an invisible, odorless gas. Atmospheric CO2 is increasing. So that's a true statement. That's a fact. Everybody agrees on that. That's not in dispute. It's very easy to measure, and so that's very clearly what's going on. The average global temperatures have increased too since modern records began. So over the past 100-200 years, there's been an increase in average global temperatures based on land records, and there's a difference. And yeah, you have now in modern era, you also have some satellite imagery, satellite records, and you have different thermometers used and things like that. So, but pretty well over a period of time, global temperatures have increased. CO2 is a greenhouse gas. It contributes to some warming. There's some absorption and adsorption of warmth with CO2, and one of the scientists in this video is a CO2 expert, and he will explain to you a little bit about how that works. So stay tuned and don't go anywhere. Certainly humans contribute to CO2, so that also means that we contribute some, has some implications in the warming as a whole. Also, people agree, when you talk to the majority and general scientists, that climate is a complex system. When you listen to Al Gore or when you listen to the media, sometimes they kind of make it all to be very, very simple. It's all about CO2, nothing else matters, and we know how everything works. Well, I'm sorry, it's not climate. It's actually what they call a chaotic system, which means it's like a ball intertwined with wool, intertwined wool. So it's all interdependencies with cycles within cycles within cycles within cycles, and all these different things that are kind of impacting and pulling on each other, that kind of have a co-interdependency and that has an actual outworking, right? So it's a complex system, and it's not fully understood. I could have put that in there as well. I think that's generally agreed that it's not really fully understood. And of course, most important is that looking after our environment is important, and that pollution must be avoided. So I think there are factors that we can all agree on. So that's without question in terms of what we're doing. So there's also some weird disagreements, and I think I want you to watch out for this as well, because it matters, right? For one is the importance of human life and human prosperity. There is a pernicious element in society that are into kind of eugenics, very nihilistic, and they think that humans are basically bugs on this planet, and we should all be made extinct, and we should not exist whatsoever. Which goes directly opposite to what my perspective is that we are important, and of course all of life from our perspective everything is here to support us, and we need to look after the environment. And humans are absolutely important, right? The importance of carbon dioxide. There's some people, some element too, that seem to think that carbon dioxide is a pollution, is a pollutant, and there should be no carbon dioxide. When, of course, in fact, it is absolutely critical to all life. All right. So you can't live without carbon dioxide. Your plants will die without carbon dioxide. So that's an distinction, but there's some disagreement there, which is kind of weird. The influence and importance of the sun. There are elements in this debate. Some clusters or groups of people that tend to think that the sun doesn't matter whatsoever. Well, all you need to do is go out into the sun and stand there for 10 minutes and decide for yourself whether it has an impact on the climate and on the weather and on temperature or not, right? So people, when you wake up, like in here in Canberra, sometimes the temperature difference between nighttime and daytime is about 20 degrees. If you live in the desert, it could be even more. Then you will look forward to the sun coming, right? So you can't tell that the sun, of course, has no importance whatsoever. It just seems weird. Also, as I said before, there's a lack of perspective, an impact perspective with some elements. Like we need to get rid of it at any and all costs. It's like just this one-track mind, blinkers on. That just a very kind of a dangerous way of thinking and very weird. Ideas about runaway and hyperbolic climate predictions, like, in 10 years' time, the ocean level is going to rise by 80 meters. Well, that's mathematically impossible. It's never happened like that in history, right? Runaway climate discussion. The climate, there's a positive feedback that keeps on positive feedback, and therefore, is going to be, all of that. Well, if it was already a runaway, if we were already there with these positive feedback loops, with the small percentage of impact that we're having, these positive feedbacks would kind of like, when you have a microphone near a speaker, cycle around, and it just keeps getting worse and worse, and there's nothing you can stop, right? It's not like, like with a microphone, when you pull a microphone away, which of course you get full control over, you can do that, but you can't just all of a sudden just suck all the CO2 out of the atmosphere. So the idea of having a runaway climate would mean that there's absolutely nothing you can do about it, and we're just here along for the ride, and that it's absolute doomsday and we're all doomed. That's some weird perspective too. I think that's for me, that's weird. As I said before, the debate is over. It's also a bit of a weird position to have in scientific discussion and in the pursuit of truth. But moreover, this whole obsession with having climate deniers and writing lists so they can keep track of people that disagree with them. I mean, gee, that's the stuff of fascism and dictator despots, right? It's that kind of attitude is extremist, and in my I don't like that at all. That's kind of very dangerous route to go and ride. It's a bit more. It's beyond weird. And then the other area that I wanted to put on this list about what I think is a bit weird in certain disagreements is the prioritization and importance of modeling over observations and logic. Right, so they're saying, it's like computer says, right? In the 80s, you had like, computer says. So people don't think that to put something in the computer says 2 + 2 is 5, therefore the computer is right, that's it. It's the same with these models. So they had models with COVID as well, as they put something in, but models, of course, are just basically man-made calculators with variables that are input dependent on what you put in. And so garbage in is garbage out. And so to pretend that the output of a particular model or forecast is more reliable than what you've actually been observing or what logic dictates is just weird, in my opinion, right? It's just crazy. Okay, so I wanted to share that. So, what is questioned? How much? And please bear in mind, I'm gonna share with you some facts in a minute, but I just feel that I want to set it up a little bit so we can just go through this, because it's all part of the discussion, just to kind of put some context around it, right? So, what is actually questioned? Well, these are some of the elements that are being questioned. So these climate deniers are just kind of sensible people that have some questions around these things. So these are some of the questions that are out there. So one is, how much of the atmospheric CO2 or carbon dioxide increase is due to human contribution? I.e., what can humans actually control? Right? Some people say all of the increase over the last 100 years has been due to human contribution. Some say that. Others say, well, only 3% is due to human contribution, or 5%, or 1%. Or others say, well, ultimately whatever's in the atmosphere at the moment is only what's left there from the last 10, 20 years, because it all gets reabsorbed automatically. So there is some questioning and debate around how much of the CO2 is actually directly attributable to human contribution. And I think the answer lies somewhere in between, but you'll figure it out. Is the slight increase in temperature in modern times dangerous? And we're always told about it being dangerous, but there seems to be no evidence that actually indicates any need for alarm now or in the foreseeable future. I mean, we've had a lot of dire predictions for the last 40, plus years, and almost none of those predictions have actually come true. A sea level rise of 2 meters, the dams will never be full again, we're going to be perpetual heat waves and all sorts of different things. It's not the case. And in fact, over time, as time increases, the number of people that have actually died as a result of extreme weather events has drastically decreased. It's just, it's really fascinating to look at. And if you look at the extreme weather patterns, even though that, the media might say, oh, there's a cyclone or there's a storm, now that's directly due to climate change. Well, there's no direct evidence for that. Of course, you can't tie a weather event directly with long-term climate changes. But there is also no evidence in the statistical records for an increase in these extreme events, right? So, is there actually, is it dangerous? Is this increase in temperature dangerous? We know it's positive, it works. It has a positive impact because of human prosperity and things like that, and the greening of the planet, right? CO2, another question is, CO2 is portrayed as the control knob of temperature and climate, but the impact is relatively small. So the question is, what is really happening in terms of positive and negative feedback principles with other factors in the environment? Because it doesn't look like CO2 can have this impact directly, right? I think there is agreement about the fact that CO2 has that direct impact. Just look at it, 400 parts per million, which is, tiny sand in a grain on a massive beach can't be, one hot piece of sand, grain of sand can't, heat the whole beach, right? It's the same thing with a tiny little bit of CO2 in the atmosphere. So there's something else going on, and so the answer's, figuring out what is going on. Is the additional CO2 dangerous because the planet is greening and plant life needs CO2, and so it has a positive impact on plant life? And why is climate science ignoring the large-scale natural variability and pretending we understand what normal is? So the notion of normal is not constant or static. Some people like to think, oh, this is a standard, right? The temperature should always be consistently at this level because that's what is normal. Well, that's not how climate and the weather works. That's not how, we do that in the health sciences as well, with blood pressure. This is the normal blood pressure. Everybody should have that. Well, that depends, on the context and things like that. So it's the same thing with science in the climate field. So let's have a look at another element, because if we're talking to students, if we're talking about teachers, if we're talking about pursuing the truth, sometimes we can get distracted and get pulled off track. And I think it's important to know and figure out if somebody is actually manipulating you or not. And there's a lot of manipulation going on. Manipulation by politicians, manipulation by the marketing, manipulation in the media, opinion pieces. There's manipulation in the classroom between, the popular kids and the less popular kids and the nerds, and, all sorts of different things, right? So in this particular sphere and field of climate, or science in general, I thought to put down a few points that you could observe or pick up on to then give you a bit of a warning as to whether or not you are being manipulated. And this is the list here. One is there's no room for debate or critique. So no debate. I'm not discussing it, that's it. So you might be manipulated, right? And it might be an emotional manipulator, emotional blackmail, right? There's a heavy use of emotional imagery or language invoking emotion. People get sensitive, people get feared, or talk about pollution, have a hungry polar bears and whatever. If there's a lot of emotion that it gets used in the media, there's other story pieces of people that have spoken out in the journalistic fields, particularly in war zones, etc., where they actually hire actors to pretend so they can film them to stir up emotion and increase viewership. That's the stuff that is happening. So when you see pictures of crying people or that pulls out, stirs the heartstrings and emotion, then you gotta watch out, right? Because then rationality goes out the window. If there's a lack of context or comparison, so when you have one side of the debate being presented versus the other side being presented, then you got to watch out, and certainly in your own mind you got to watch out that if you can't think about how a person could come to a conclusion on the opposite side of the debate, then perhaps you've got it you're on the wrong side of the debate. If you don't understand how people can actually draw that conclusion, then perhaps you haven't really thought through both sides of the aisle or both sides of the argument. So there is, for example, a heavy reliance on modeling or predictions rather than observations. There's also being manipulation, right? Because models are being manipulated. It's all about variables that they have in control. They can make it do whatever they want it to do. Sense of urgency and fear. So no time for this. You got to do it right now, buy now, only today, only one left, 10 left, whatever, and there's overwhelming consequences. So you put on a spot, right? Oh, it's for your kid's future or this or that, right? It's bringing everything together. Lack of nuance. So, for example, conflating environmentalism with climate science. You're bringing things together. Or use of irrefutable statements like truisms and circular references like climate change. Well, what does that mean, climate change? The weather and climate is always changing. There's a natural variability. So how do you refute the argument climate change, right? So it's a truism. So there's a lot of these kind of media and political statements that you can't refute, and when you see those, they're hard to argue with. It doesn't mean that the cause of what they're actually having underneath it or what they mean by it, that is actually a good thing, right? So a I want to go, before I get into the more detail, I know it's been a while already, but stick with me because you're going to enjoy this. A few basic scientific areas so that we're all on the same page. It's important to be on the same page. So I want to make sure that you understand where I'm coming from. So climate change is not environmentalism. I already mentioned it before, is that, because you dispute CO2 narrative doesn't mean that you don't want to look after the environment, right? Just to have your environmental, that you're denying CO2 is the control knob doesn't mean that you're an environmental vandalist, right? Whereas you could be pushing for absolute zero emissions of CO2 and zero CO2. That could be both eco-vandalism as well as economic suicide, right? So you got to be careful with that. Those two are very different things. Causation must have correlation. So there's another thing to really bear in mind. It's very, very important for you to understand that the cause, if you're saying this causes A causes B, then A must always precede B and A must always be near B, right? They must always go together. So causation must have correlation. But simply because A and B are together at the same time doesn't mean that A causes B, right? So it's important to understand that. You may not be taught this, but correlation is not the same thing as causation. But causation must always have correlation. Scientific evidence requires tested outcomes to be repeatable, so not just simply ideas or thoughts or hypotheses, right? If something is to be true, you must be able to go back and retest it and have the data there again and then go through it again and have it tested. It should be repeatable, right? That's the scientific method. And as I said before, models are not reality, so computer modeling is not reality itself, so presumptions are not the same thing as observation. Now let's go into the evidence, and again, it's really what I'm preparing here for you is a bit of evidence against the simple and easy CO2 narrative that you hear in the mainstream media, politicians, and hear all the time. And because you hear that all the time, I'm just bringing you a very short summary to give you a little bit of a different perspective and something to think about. And then you can follow that up for yourself and decide for yourself if you have a good balanced perspective on things. So we'll go through some historical observations and geological records. And I'm not going to tell you this. It's not going to be my voice. It's going to be the voice of actual scientists, credentialed scientists, PhD professors, specialists, experts in the field, right? And I'll share with you some of them as well as to, what their credentials are. And there's links there in terms of videos, and you can go and chase it up, and I'll give you everything so you can just do your own research, right? So some of the actual observations, which of course is important because that's what we're talking about, and then CO2, the molecule itself, and some mathematical reality check because, things have limitations. So let's just go through this. Hope you're ready. Sip of water. Been talking too much. Let others do the talking now. So the first one is a true climate expert, professor, doctor, and they're doctors because they're PhDs, they're doctor in science, right? Doctors in science. Don Easterbrook, and there's a wonderful video that he's given elaborate testimony in the US Senate. And so he's got a PhD in geology from University of Washington, Professor Emeritus of Geology at Western Washington University, and he was the chairman of the department for 12 years, active environmentalist, as I said. People do want to look after the environment, right? And he is dealing with undergraduate programs in environmental geology and has had the National Award for Distinguished Service to the Quaternary of Geology and Geomorphology Division and a Lifetime Achievement Award, and is the author of Evidence-Based Climate Science. His conclusions in general, so just a summary, that global warming is real, so there is warming, but it's not caused by carbon dioxide. There has been no warming effectively for the past 18 years. Now, this was a few years ago. CO2, carbon dioxide, cannot cause significant global warming. There is no correlation between CO2 and warming. That 8,500 of the past 10,000 years have been warmer than the current time, than the present. So the whole rhetoric about is unprecedented, is the hottest year on record, all that kind of stuff, that's really not true. That Antarctic ice is growing and not melting, and we have records for that. The satellite records clearly show that. That there is strong evidence the sun has controlled the climate over the past 11,000 years and not carbon dioxide. The polar bears are fine, and he's not the only one to say that, and that the 97% consensus is an absolute hoax because it only reflects 75 scientists through the studies that they have selectively picked. So let's just hear from Professor Don Easterbrook.
Looked at what CO2 has in common with temperature. Here's where, this is about 1945, this is where the emissions began to rise sharply. And we have 30 years of global cooling. And before that, from 1915 to 1945, we had global warming without any increase in CO2. So who needs CO2? And it gets even more than that. In this graph, I plotted temperatures from isotopic evidence in ice cores. The red peaks are periods of global warming. And there are 20 on this graph, dating back to about 1500. If you go back even farther, if you go back 10,000 years, this is 10,000 years ago, this is the present, temperatures are about 2.5 to 5 degrees warmer than present in Greenland. No CO2. And then about 1,500 years ago, we dropped into what has become the Little Ice Age. Going back even farther, 25, 30 years, 1,000 years, we have the last ice age with huge warming of 20 degrees in less than a century and dropping of temperature of 20 degrees in perhaps around a century and rising of temperature about 20 degrees in a century, all without the benefit of CO2. Second line of evidence is that CO2 cannot cause significant global warming by itself, simply because the amount of CO2 in the atmosphere is minuscule. If you double nothing, you've still got nothing. Not only that, but CO2 is a greenhouse gas. It accounts to only about 3.6% of the greenhouse effect. 95% is water vapor.
All right. Well, you've heard from Professor Dr. Don Easterbrook himself. And just a quick point to add there about Greenland, because he talks about the ice cores of Greenland. Greenland is called Greenland because it used to be green. There used to be farms there in the medieval warm period, and there used to be in the within the Antarctic circles, and Greenland is certainly near there as well, trees growing, and they haven't been since, so it's a lot cooler today than previously, and so there's the evidence there. Now let's hear in terms of other historical observation and records here in Australia from Dr. Daniel Fitzhenry. He's an hydrographic surveyor. He was interviewed at the Bolt Report and Sky News, and here's what he's got to say about the water levels, the ocean levels. Of course, they take accurate measurements here in Sydney, New South Wales, and a clear precursor that I want to let you know beforehand, that if there was any evidence of a melting ice, then we should see sea level rise significantly, right? And because that's, of course, the evidence that should be showing up if that were true. Let's hear what he's got to say.
And the Bureau of Meteorology has been checking records there for more than a century, and there have been other records going back further again. Can you tell us what the records show?
Well, the Bureau of Meteorology started mean sea level records in 1914. They show the highest levels of the tides, the lowest levels of the tides, but mean sea level is the one that we need, say we wanted to calculate the volume in the oceans, or if we want to calculate if sea level is rising or falling.
But when you look at the data that you've, when you look at the data, you see 1914, then it's pretty high, then it stays high for, a couple of decades, a decade and a half, then there's low levels for 3 decades, then higher again at the end of the century. But since then, the last couple of years, it's trended down. It's actually lower now, according to your data, than it was in 1914. What does that tell you?
Well, right now, the sea level at Sydney is about 6 centimetres lower than it was in 1914. Now, sea levels are affected by, on a day-to-day basis, by the moon rotating around the Earth. And in the long term, the small pluses and minuses in mean sea level is affected by the planets moving round the sun in elliptical orbits, and sometimes they're closer to the Earth than they are at other times. So mean sea level varies up and down in the range of 20 centimetres.
All right, mean sea level varies by about 20 centimetres, and current records show at Sydney in the ocean that the ocean is lower, about 6 inches. All right, well, let's have a look at a rock expert, a geologist, right, from Brown University, PhD. Now, I must say that he's a professor of astronomy and planetary sciences at the Department of Physics in Central Florida. He does research on properties of mineralogy and asteroids and comets, and he's been involved with that with NASA, and he's a fellow of the Meteorological Society and has an asteroid named after him. So he's a rock expert, true rock expert. And so he says that geological rock records have a high level of certainty to identify ice ages. We are currently in an extraordinary cool period, ice age, that the interglacial periods seem to perfectly line up with Milankovitch cycles, i.e. that the Earth's relation to the Sun, and that Milankovitch cycles have dominated our climate. That any other climate factors simply disappear in the noise and are indistinguishable. Now, based on Milankovitch cycles and low solar input, that we should be getting better to a colder climate, and that we're progressing towards another ice age, but we are not. Now, he does blame agriculture and CO2, so he is not a denier in the same sphere, but he does know about geology and rock records, and that's what I'm sharing them here with you for. So this is Professor Dr. Daniel Britt, geology expert.
Science, we're always groping for answers and testing these answers. So, we know that, so there are various grades of how well you know things. This is a pretty high grade. We know this pretty well. And so what's normal for climate? This is Phanerozoic. Phanerozoic is what you live in today. That's the period when you have like complex critters. We are here at 0 in the Neogene. Go back a 500 million years. And the first thing you see is that it is about as cold right now as it has ever been in the last 500 million years. We are actually in an extraordinarily cold period. We are in an ice age today. we're in a relatively warm period of an extremely cold period. You know, I didn't say this was going to be easy. This is, you know, reality is just, I'm not going to sugarcoat reality. This is reality. And so we were very cold. Back during the Cretaceous, the K means Cretaceous, scientists don't spell well. It was extremely hot. But average for Earth is a lot hotter than it is today. But what you should take away from this slide is there's nothing normal about climate. Climate varies a lot. And it varies a lot for very good reasons, which we can figure out, and which we will figure out tonight. The guy who puzzled this all out was a Serbian mathematics professor called Milenkovic. Back in the early days of the 20th century, this was big science. The question of why there were ice ages. Because you could see abundant geologic evidence that there were at least 4 big ice ages, 4 big glaciations in Europe and North America. And the burning question was why? And this guy decided that the way to figure this out was to look at variations in the solar flux at high latitudes. And you can vary that solar flux at 65 degrees north latitude by as much as 25%. But the way to prove this was that you had to do a bunch of spherical trig and figure this out over the last 250,000 years. And what he found was that if you look at these cycles, that the orbit of the Earth's orbit actually affects the amount of sunlight you get tremendously, because there's an eccentricity cycle that goes from about 0 to 6 degrees in the roundness of the orbit. There's a tilt cycle that goes from about 24 to 21.5 degrees, and an index of precision, where you are in the orbit when you're closest and farthest from the sun. And you can combine all these effects and actually see how much sunlight you get at high latitudes. And it turns out that just lines up with the relative cold and hot in the climate. This is more of the data that I took. And so there's the 100,000 year, this is hot, this is cold, this is right now, this is roughly 100,000 years ago. That's the previous interglacial. This is the eccentricity cycle, 100,000 years. There's the precession cycle, 23,000 years. That's the tilt cycle, 41,000 years. It lines up. These orbital changes absolutely dominated our climate for the last 500,000 years.
All right, so now we have another climate expert, Professor Tim Ball, and we're near getting to the end of it. As I said, we just have some historical observations, some geological records, and then we'll just move on to some different science. So he has a PhD in geography and climatology from the Queen Mary University in London. He's a former professor of geology at the University of Winnipeg. There's an example presentation linked there for you as well. His conclusions that the polar bears, they're fine and they're thriving, which they are, that CO2 does not raise global temperature, and that the increase in CO2 in the atmosphere is actually the effect of warming and not the cause. That CO2 is not a pollutant, but extremely important. I think there's a lot of consensus around that, except for some weird ones. The ocean is not actually acidic or acidifying, something that is a little bit less base is still base, right? And that man cannot and does not control the climate. So let's hear from Professor Tim Ball.
What this shows, this came out in 1991, and it was presented as proof that CO2 was driving temperature. Here's the current temperature of the Earth over here, and the blue line is the temperature, the red line is CO2. And the French researchers that brought this out, to Petit and Jouzel, But they were warning. They said, don't rush to judgment on this graph. Because if you look at this graph, when it's in a book, that's about 4 inches of graph that's covering 420,000 years. How much detail can you see? The answer is virtually nothing. Okay? Well, within 5 years, and they were saying, oh, this is proof. This is what these people that were using climate for a political agenda, they said this is proof that the temperature is driving, or CO2 is driving temperature. We knew within 5 years that it showed exactly the opposite. That the temperature changes before the CO2 changes. But what's the whole fundamental assumption that they make? They say, oh, CO2 goes up, the temperature will go up. That doesn't occur in any record anywhere in the world at any time in history. Nowhere. In fact, exactly the opposite happens. So the fundamental assumption they make about CO2 and temperature is wrong. But they blithely carry on because they know the public don't know that and don't understand that. So you can see that here. By the way, well, I'll show you another graph. This shows you 600 million years of the Earth's history. And I love it when they come on the radio and say, oh, it's the hottest day ever. Oh, boy, am I glad I lived long enough to see this. And I like to phone in and say, do you really mean ever? Well, no, it's in government record. Oh, that. How did we ever survive before there was government? My goodness, this is amazing. And of course, that's something that you've got to look at. What this shows is the current level, CO2 is the red line. And here we are at the current level, 400 parts per million of CO2 in the atmosphere. And Al Gore tells you that's the highest level we've ever had. Look at this graph. It is in fact the lowest level we've ever had. Okay? And in fact, you could argue, looking at here, the last 300 million years, that the CO2 level has averaged around 1,000 to 1,200 parts per million. 3 times what we've currently got. And do you know how we know that's important to the Earth? Because if you go to the greenhouses on the coast here, the commercial greenhouses, they pump up to 1,200 parts per million of CO2 to get the plants to grow more vigorously. In fact, you could, and Dr. Idso has done 30 years of research showing that increased CO2 increases the yield of the plant. And it also, by the way, reduces the amount of water it uses. So I think that that's 300 million years of evolution of plants to an optimum level of about 1,200 parts per million. So you could argue, say, the plants are malnourished at 400 parts per million.
Okay, then we have a real, and this is phenomenal. So Professor William Happer, he's the world's leading scientist on CO2, the molecule. He's got a PhD in physics from Princeton University. He's got the Cirrus Fogg bracket. He's a Cirrus Fogg bracket professor of physics emeritus at Princeton, and he's the member of some advisory group and director of energy research with the Department of Energy, and appointed on the Presidential Committee for Climate Security, which he's since resigned of, but he's also won the Davidson-Germer Prize in Atomic or Surface Physics. Again, there's the presentation link that you have there, will be linked below. And what he is saying is that CO2 is not a pollutant, that CO2 is absolutely critical for plant life, and that any increase is likely to do more good than bad. That carbon dioxide is an important trace gas and an integral part of the carbon cycle, a biogeochemical cycle in which carbon is exchanged between oceans, soils, rocks and the biosphere. That CO2 concentrations have been as high as 4,000 parts per million and as low as 180 over the past 500 million years, and that we actually are currently coming out of a carbon dioxide drought. That CO2 levels since 1880 have risen from 240 to 413 in Hawaii. That there is an impact on temperature rise, that it is logarithmic, and that it's most of the effect that CO2 might have has already occurred, and that at best, if the hypothesis is true, that there's another 400 parts per million increase, that will take another doubling to get only 1 degree centigrade in actual degree change, if that is true. and that the impact of CO2 has been largely misrepresented, and that the climate models are unable to predict accurate climate outcomes because they fail to take into account the complexity of factors that are involved. Here's Professor Dr. William Happer.
Obviously it's important. It does change. There's very little evidence that humans are making much impact. And as far as CO2 is concerned, which is the major focus, that's probably more good than bad.
Now, I can hear people yelling at the screen right now saying, what do you mean CO2 doesn't make much difference?
Well, you know, I know a lot about CO2 compared to most climate scientists because we make CO2 lasers, you know, and CO2 is a very interesting molecule, and the particular mode of CO2 that contributes to global warming, CO2 is a rod and it bends like this, up and down, and it's that bending motion that causes the global warming. But that is such a strong absorption that it's saturated now. So as you add more CO2, most of what you can do has already been done. There's still a little addition, but not very much.
Can you explain that to me in a little greater depth? What do you mean it's already been done?
Well, if you have a barn, you know, and you want to paint it red, you know, if you put a thin paint of red paint, it may not be quite red enough. If you put 2 or 3, then it really looks red. After that, if you add more red, it doesn't make much difference. And so that's sort of what CO2 is doing now, that most of the easy absorption has been done. And so as you add more CO2, you get a little broadening. I don't want to get too technical.
Well, no, I find this fascinating because, and the reason that I find it fascinating is that I hear that, okay, we've gone from about 320, 330 parts per million going back in the last 100 years now to just shy of 400 parts per million if we measure it in Hawaii. And along the way, we've heard predictions of different catastrophic outcomes as we push our way through different maximums.
There's an interesting thing about CO2, which is unique to CO2. It's not true, for example, of water vapor or methane, and that is that if you get 1 degree of warming from doubling CO2, so going from, say, 400 parts per million for simplicity to 800, that doubles it. Suppose that causes 1 degree of warming. Then to get another degree of warming, you have to double 800, so you have to go to 1600. So you have to double it again. So it gets harder and harder to warm. Technically, they call that the logarithmic dependence of temperature rise on CO2 concentration. It was first guessed at really by Svante Arrhenius, you know, who did some of the earliest work on global warming. He thought it was good, you know, he was all for global warming. But he was the first one to point out this doubling property of CO2. Nobody quite knows how he guessed it. It's correct.
Because he wasn't using computer models.
Well, I mean, it was before quantum mechanics, you know. He didn't even know about spontaneous emission. It was before Planck. But nevertheless, he guessed it correctly.
And now let's go into a mathematical limitation. As I said, there's a few perspectives. So let's have a look at some of the mathematics behind it. So here's Professor Murray Selby. He's written a book, Physics of the Atmosphere and Climate. And he's got a PhD in environmental dynamics from Georgia. He was a tenured professor at the University of Colorado. He was actually in Australia, Macquarie University, and he was fired from that. But he was the first to document the influence of meteorological variability on long-term stratospheric ozone changes and was recognized by the World Meteorological Organization. So his conclusions are that climate sensitivity is below 0.2 degrees Celsius, and he's confirmed that with 3 different independent methods in his overall presentation. Most of the observed increase is not anthropogenic, that CO2 movements and concentrations are largely determined by nature, and that any cuts will not have the desired effect, and that whether CO2 is man-made or not does not drive the climate system. So here is Professor Murray Selby, an excerpt from his presentation to give you a taster and a summary of his perspective.
The research I will describe goes to the core issue of climate change. Why is atmospheric CO2 increasing? The IPCC's position is exclusive. Increasing CO2 results from anthropogenic emission entirely. The analysis about to unfold was inspired in significant part by the following observation. During the 1990s, the rate of fossil fuel emission increased almost linearly, growing each year by 0.08 gigatons of carbon per year. Were it retained in the atmosphere, that growth of emission would be equivalent to an annual increase in the growth of atmospheric CO2 of 0.04 parts per million by volume, ppmv, per year. After 2002, fossil fuel emission also increased linearly, but 3 times faster. By the end of the period, fossil fuel emission was almost twice as great. During the same period, CO2 increased linearly, especially after 1995, when it increased at about 2 ppmv per year. After 2002, CO2 also increased linearly, but at exactly the same rate. The growth of fossil fuel emission increased by a factor of 300%. The growth of CO2 didn't blink. How could this be? Say it ain't so. If you step back from the stream of increasingly absurd claims and consider the big picture, the observed behavior should hardly come as a surprise. This is an estimate of the CO2 budget by the IPCC itself. It's the checkbook of CO2, the financial ledger that determines its balance in the atmosphere. The human source is of order 5 gigatons per year. The rest involves natural sources and sinks. They are larger by 2 orders of magnitude. Of total emission, natural emission accounts for over 95%. Net emission is the balance of these entries in the CO2 checkbook. For it to be dominated by the anthropogenic component, natural emission and absorption would have to remain perfectly in balance. Even a minor imbalance would overshadow human emission. Of those dominant contributions to the CO2 budget, our knowledge is limited. Observations of natural sources and sinks are scarce. Their collective impact, however, is unambiguous. In the atmosphere, CO2 is conserved. Once introduced from the Earth's surface, it's neither produced nor destroyed. It's only rearranged by the atmospheric circulation. The rate of increase of atmospheric CO2, its growth rate, must therefore equal its rate of net emission from the Earth's surface. Embodied in this equation is the budget of atmospheric CO2, which determines its abundance. Net emission is just the sum of emission by all sources, minus the sum of removal or absorption by all sinks. Among the sources is human emission. Everything else is natural. By the IPCC's own estimate, the human contribution is small. The rest, from natural sources and sinks, represents more than 95% of what determines atmospheric CO2. Net emission is a resultant of all contributions. It must equal the instantaneous growth rate of CO2. That property is derivable from the observed record of CO2. In green is net global emission of CO2 from all sources and sinks. Does net emission resemble the human contribution? Not really. The observed evolution of net emission bears no resemblance to its contribution from fossil fuel emission. In fact, the two records are incoherent. Net global emission evolves independently of the human contribution. Okay, is the discrepancy from fossil fuel emission small? Not really. Observed changes of net emission are huge, as large as 100%, as they are absent in the contribution from fossil fuel emission. Those changes of net emission can follow only from what remains, changes of natural emission. If net emission does not resemble human emission, what does it resemble? A clue comes from the evolution of CO2 during the last 2 decades. The growth of fossil fuel emission increased sharply by 300%. The growth of CO2, which follows from all contributions, remained constant. During this period, one other property also remained constant. Since 1997, global temperature has varied little. Except for weak cooling, it remained constant. Unlike observations of CO2, observations of its emission are scarce. All we have are local field measurements. They are few and far between. Nevertheless, those local observations reveal that CO2 emission is sensitive to surface properties of land as well as ocean. In contrast, anthropogenic emission is independent of surface properties. The sensitivity of emission observed locally is confirmed in the evolution of global CO2. In blue is the component of net global emission that operates dependently with surface properties. It tracks the observed evolution of net emission. The blue curve represents changes of CO2 emission that are induced by changes of surface properties. Achieving a correlation of 0.93, the induced component accounts for nearly all of the history of net global emission. The surface properties on which national emission depends are diverse, but one carries the lion's share. Temperature by itself achieves a correlation to the observed record of 0.8. It drives the thermally induced contribution to CO2 emission. As we've seen, net CO2 emission depends strongly on temperature. This makes CO2 dependent on temperature. That dependence is measured by the cross-correlation with temperature, not of CO2 emission, but of CO2 itself. Plotted here is the cross-correlation between CO2 and temperature as a function of lag between those properties. It measures how large of a change in CO2 results from a change in temperature, along with the relative timing of those changes. Their cross-correlation is significant across a wide range of positive lag, where changes of CO2 follow changes of temperature. An increase of temperature is followed 10 months later by an increase of CO2. Hence, like emission, CO2 is strongly dependent on temperature. Its lag behind temperature leaves unambiguous which is the horse and which is the cart. This leaves global temperature to be controlled by just about everything but fossil fuel emission.
Here's a climate expert, Professor Richard Lindzen, and he's got a PhD in applied mathematics and a BA in physics from Harvard University. He was the Alfred Sloan Professor in Meteorology at Massachusetts Institute of Technology, and he's held positions with the National Center for Atmospheric Research, the Institute for Theoretical Meteorology, and Harvard University, and he's published more than 200 scientific papers and books, and was the lead author of the IPCC's third assessment report, and he wrote Chapter 7, Physical Climate Processes and Feedbacks, and appeared in the Great Global Warming Swindle documentary. His conclusions: there is no cause for alarm, and there's actually hundreds of scientists that actually state that there is no alarm, that the 97% agreement is actually a bogus claim, that much of science presented is based on a false narrative and exaggeration, lies and cherry picking, that overall humankind has flourished and benefited from the increased temperatures and increase in CO2, that CO2 is a plant fertilizer and that it actually reduces drought vulnerability, and that there is a real moral concern by policies based on false trust placed in climate alarmism, that it will prevent developing nations and the world's poorest from prospering. And he has a really strong point there. So here is Professor Richard Lindzen.
So where are we? Misrepresentation, exaggeration, cherry picking, or outright lying pretty much covers all the evidence. So we reach a conclusion. There you have it. I mean, implausible conjecture, backed by false evidence, or less kindly, fake news, and repeated incessantly, has become politically correct knowledge. And it is being used to promote the overturn of industrial civilization. False claims about 90%, 97% agreement will not spare us, but the willingness of science to keep mum is likely to much reduce trust and support for science. And perhaps this won't be such a bad thing after all, certainly as concerns official science. There's at least one positive aspect to the present situation. None of the proposed policies will have much impact on greenhouse gases. Thus, we will continue to benefit from the one thing that can clearly be attributed to elevated carbon dioxide, that is, namely, its effective role as a plant fertilizer and a reducer of the drought vulnerability of plants. Meanwhile, today, the IPCC is claiming that we need to prevent another 0.5 degree centigrade of warming, since the 1 degree centigrade that has occurred so far has been accompanied by the greatest increase in human welfare in history. As we used to say in my childhood home of the Bronx, go figure.
All right, now let's give you another sense, a bit of a sense of the number of expert climate scientists that are actually speaking out against alarmism. These are all published, authored, credentialed, PhD professors, scientists, experts leading in this field, in that specific field, all related directly to climate, that are speaking out against it. And there's 3 different links that I have described there where you can actually get to find. One of them is one of those so-called lists that actually Wikipedia has removed. So do your own research and see for yourself. Listen to real expert scientists. Don't follow politicians, government bureaucrats, TV personalities, and media, because they will just present you a political narrative that is good for selling, advertising and be political or get funding and those kinds of things. Listen to the narrative or the evidence that is being presented and allow it to be tested on a basis of fact and evidence, right? So see what they present. So there you have it. So it's plenty of them there, and this is only just a limited list, right? So one other element you can see is 906 climate scientists and professionals that have made a world climate declaration. There's a link below. It's part of the Climate Intelligence Group in the Netherlands. And the summary of their particular position is that natural as well as anthropogenic factors cause warming, that warming is far slower than predicted, that climate policy relies on inadequate models, that CO2 is plant food and the basis of all life, that it's not a pollutant, that global warming has not increased natural disasters, and that policy must respect scientific as well as economic realities, and finally that there is no climate emergency. Here, as I said in my intro, there's a book there that presents the facts with scientific experts. I highly recommend you purchase this book or this series. There's multiple books in this series. You have to kind of go on a hunt for them. But there's a number of different expert scientists there, the list you see before you, writing about their areas of expertise and showing you what the facts really are. Over 31,000 scientists in America alone. So this is a national petition that have signed this statement rejecting any climate alarmism to say that there is no convincing scientific evidence that human release of carbon dioxide, methane or any other greenhouse gases is causing or ever will in the foreseeable future cause catastrophic heating of the atmosphere and disrupt the Earth's climate. And if you really wanted to sum it all up into one particular picture, as I said to you before, that causation requires correlation, right? So they have to be perfectly in sync always. If CO2 drives the temperature, then CO2 must always increase at the same time or just before, right? Temperature increase. And that they have to go up in harmony if that is the dominant factor in climate. But here you see in the records across geological timescale, which you've heard now a couple of times before, there is not that correlation. There you have it. Now, if you wanted to take some homework, and if you're in a classroom, if you're a teacher, here's a couple of questions that three questions that you can take to your students to get them to think a little bit more. First one here is logic, about logic, so testing logic. CO2 has been increasing steadily over the past 100 years, which is fact, from around 300 to 400 parts per million, roughly. So if there is no change to this trend, then this trend is most likely, likely, unlikely, or highly unlikely to continue. Let's go biology for the biologists out there. So the botanists explain that photosynthesis is a process through which plants use sunlight, warmth, water, and something to grow and produce oxygen. And what is that something missing? It's a few mathematical questions because, reality matters, right? And this is how we measure things and this is how we calculate things. It's important. The carbon cycle shows CO2 adsorption and absorption in the atmosphere from various sources. The total human contribution is generally agreed to be about 3%. Australia contributes approximately 1.3% of the total global human contribution of CO2. This amounts to 0.03 times 0.0013, which equals, this is almost giving it to you on a silver platter to see what that contribution is. But then you take that and say, if it is true that existing emissions are directly causing another 1 degree Celsius by the year 2100, being about 80 years from now, and assuming Australian contribution remains constant, than halting all CO2 emissions to a full zero emissions basis. So cars, factories, agriculture, humans breathing out today, if we stop everything today, then it would lower the global temperature by something degrees Celsius and slow it, reaching 1 degree by 1/8 times equals how many years? Here's a question for you. You can do the math and see where it's really futile what we're doing or not. It matters, right? Because we can solve real world problems. So mathematics, as a greenhouse gas, CO2 has a declining heat absorption and radiative effect, which with an estimated effect, without taking into consideration any other feedback mechanisms, such as cloud or humidity or whatever, of between about 0.6 and 1 degree Celsius of average warming for every doubling. So let's just, just presume we're going to accept that. So with the current trend average then, since 1920, from about 300 parts per million to starting today at about 400 parts per million, it will then take another how many years to have another 0.6 or 1 degree warming contribution to atmospheric CO2? How many? As a question. There you go. Anyway, thank you very much for watching this. Be happy. Don't panic.